Let us talk about this problem. We are given an array of integers. Our task is to find the minimum difference in this array. For example, if we are given this array, our minimum difference is 3 and we get this minimum difference by subtracting 5 from 8. Let's see this example where we have only two elements. So when we have only two elements, the minimum difference is only the difference between these two, right? So our answer is 15 minus 8, 7. Here's one more example. The minimum difference that we get is by subtracting minus 1 from 0, right? 0 minus minus 1 is plus 1 and we get the minimum difference as 1. If we have only single element, then we are going to return infinite. In C++, you can return int underscore max. In Java, you can return integer.max value. So please pause this video and try to write down a function that takes an array as input and returns the minimum difference. Let's first talk about a naive solution to solve the problem. The idea of this naive solution is consider all pairs. For every pair, find the absolute value of difference. And if this absolute value of difference is less than the result so far, then update the result. We initialize the result as infinite, int underscore max in C++ and integer.max value in Java. So if you have an array like this, a0 to an minus 1, and if you are at element ai, what you are going to do is, you are going to consider every element aj from a0 to ai minus 1 to consider every pair. And you are going to find the difference between ai and aj, right? You are going to find the absolute value of this difference and then you are going to compare it with the result so far. So this way you will be able to consider every pair. See, for ai we have considered, we have paired it with all the elements before it when we are at ai, right? And all the elements after it are anyways going to pair with it, right? So that way we have paired ai with every element. Right, so every element is paired with every other element and this way we have considered every pair and find the difference. So this is the implementation. I have written pseudo code here, right? I have initialized the result as infinite. Infinite means integer underscore max in C++, integer dot max value in Java. So what I've done here is I've run a loop for I equal to 1 to n minus 1 because we are going to begin with second element. For first element there is nothing before it, right? So for every element ai, we are going to run a loop from 0 to I minus 1 and we are going to compare the absolute difference between ai and aj with result, right? And if the absolute difference is less, we are going to update the result and at the end we are going to return the result. So if I is 0, I is 1, we are going to run for j equal to 0. Initially result is infinite, it's updated to 2. Then for I equal to 2, we run two iterations of the inner loop for 0 and 1 and we get the differences as 3 and 5. So they are greater than 2. We don't update result. At the end, we have result 2 only and we return the result. Now, what is the time complexity of the solution? It's clearly big O of n square, or you can say theta n square also because we do not have any break statement inside it. So the time complexity is clearly theta n square. Basically we are considering every pair n into n plus 1 by 2 sort of expression we get, which is theta n square. Now please pause this video and think of a solution which takes less than theta n square time. Let's first talk about the idea of the efficient solution. The idea is if you can somehow rearrange the array in such a way that every element is close to its value wise closest element, then you just need to find the difference between current element and its value wise closest element. If you are able to do so, then you don't need to compare the current element with any other element because the minimum difference will be with the value wise closest element for every element. Now please pause this video and try to think of a solution that rearranges array in such a way that for every element we have the value wise closest element. The idea is simple. We are going to sort the array. Once you sort the array, then every element is going to be surrounded by its value wise closest elements. For example, if I have 10, 3, 20, 12, it's going to become 3, 10, 12, 20, right? And every element now has its value wise closest smaller and greater elements, right? Except the first and last. First has value wise closest greater next and last has value wise smaller previous element. So once you have arranged in such a way, you can just traverse this array and you can find the difference between adjacent elements like 10 and 3, 7, 10 and 12, 2, 20 and 12, 8 and just return the minimum of these differences which is 2, right? So you have the enough idea now. Please pause this video and write down the code. Here is implementation of the efficient approach. We are going to first sort this array. So for this sort, we need to include algorithm in C++ and we can do arrays.sort in Java. For that, we need to import java.util.arrays. So if you are given this array, your array will become after sorting, right? You will have 1, 4, 8, 10. After that, we are going to initialize our result as infinite in .max in C++, int underscore max in C++, and integer.max value in Java. Now we are going to run a loop from the second element. We just need to subtract the previous element from every element to find the difference, right? And for first element, there is no previous. So we are going to begin from after sorting from 4. We are going to subtract previous element. We are going to get the difference as 3, right? So 3, we compare with infinite, we get the less value as 3. Then we come to 8 and we subtract 4 from it. So we get the difference as 4. Now we come to 10 and we subtract 8 from it. So we get the difference as 2. So our final result is 2 because 2 is the smallest difference. And we are finding the minimum value here. In Java, we can simply need to use mat.minimum. What is the time complexity of this? As a first step, we are sorting the array. Sorting takes big O of n log n time. So it takes big O of n log n time here. And then this loop takes, this whole thing takes big O of n time. Or you can say theta n because we are running a loop from 1 to n minus 1. So that takes theta n. So overall time complexity is going to be this plus this, which is going to be big O of n log n.